Sellin is here. He's our wise guy with the science behind soap bubbles. So had some cool stuff, and we got the black light out, so it's going to be really cool this time.
I'll always think of bubbly now when I see you. Yeah, so we're going to do some stuff with the black light here in a minute, but I want to show you something cool first. Just to show you...
Is this special science soap?
No, this is like dishwashing liquid mixed with some water and a little bit of glycerin from the drugstore. I'm going to put a recipe on the website as soon as I update it, which is hopefully going to be tonight. Okay. We'll see how that goes. So I just want to show that these soap films behave kind of like a rubber sheet. So here I have a loop, a wire, with a little piece of wire that's in between. And I have this other little piece of wire. It's free to move back and forth. Right now there's soap films on either side. Take your finger and poke it on one side.
Just stick it right through?
Yeah.
Slowly? Or?
No, just poke it in there. You see, you broke the soap bubble on that side, which is like a rubber sheet, and the sheet that was left on the other side pulled it over because it's very elastic. That just kind of proves that this stuff likes to shrink whenever it can. Okay, so here's what I want to show folks right now. I want to blow a bubble.
Is that a special science straw?
Now, if we zoom in on this bubble, you'll see some fascinating colors. Get down here and you'll see yourself. You see how they sort of shimmers and you get different stripes and there's purple and kind of a rainbow of colors. The reason for that is that this film is very, very, very thin. The skin of a soap bubble is a thin layer of water, and on either side of that layer of water you have some soap molecules that are sort of decorating it, which are keeping it from evaporating and reducing the surface tension a little bit. So it's very, very thin, and whenever you have a very, very thin film of anything, you get light bouncing around inside it, and you get this sort of diffractive effect. And so depending on exactly the thickness and so on, you see different colors of light, the thickness and the angle and things like that. So you get these beautiful, beautiful colors.
You know, why is this constantly in motion? Is that the actual water trying to kind of flow around the...
I think it's the soap molecules and things are just kind of rearranging themselves in little sheets, and it's just fascinating. Okay, so I want to do one last thing. If you'll dim the lights real quick, I have a black light and I have some special soap solution.
Oh, cool.
Isn't that cool? So you can get this stuff at the toy store, and isn't that interesting?
These bubbles are beautiful. 29-cent soap bubbles we give our kids.
Well, basically, these soap bubbles have a little fluorescent dye in it so that you can see it under the black light. But you can buy this stuff too. I just think that's beautiful. So anyways, we should turn the light back on because people want to see you when you're talking about the weather, right?
We're finding out that science is behind everything.
Science, of course it is. And we're going to do weather next week, by the way, because science is behind weather, too.
Okay, we can weather topic next week. It's Matt Sellin. He's the wise guy on the morning show. If you've got a question for Matt, you can email him directly to his website, which is
wiseguy.net.
Wiseguy.net, or you can send it to the morning show website, and we'll link it to him for you.
Thanks, Robert. Coming up for you on the morning show, hike